The paper discusses the evaluation of natural language generation, NLG, using in-context learning with large language models, LLMs. It proposes a novel approach to multidimensional text evaluation, focusing on dimensions such as consistency, relevance, fluency, and coherence. The method uses a simple prompt design, which consists of a few in-context examples, to evaluate the quality of generated text without requiring large annotated training data. The authors demonstrate the efficacy of their in-context learning-based evaluator (ICE) framework on text summarization, achieving competitive performance with state-of-the-art trained evaluators on dimensions like relevance and factual consistency. They also analyze the effects of factors such as the number of in-context examples and sampling procedures on performance. Additionally, the paper explores the effectiveness of ICE in evaluating zero-shot summaries generated by LLMs like GPT-3, finding close agreement with human judgments. The research paper discusses the evaluation of summarization systems using the SumEval dataset. It presents a novel evaluation framework, ICE, which is compared to state-of-the-art multidimensional evaluators like CTC, BART-Score, and Uni-Eval. ICE achieves competitive performance without requiring fine-tuning and outperforms Uni-Eval in consistency and relevance. The paper also analyzes the effects of prompt engineering choices, including the impact of sampling procedures and the number of in-context examples. It suggests using uniform sampling for its stability and close alignment with the true distribution, even though it may not perform optimally in all dimensions. The study's findings indicate that ICE is a robust and effective evaluation framework for summarization systems. In the realm of natural language generation, NLG, evaluation, a novel approach has been proposed, leveraging in-context learning, ICE, as an alternative to fine-tuned evaluation metrics. This method uses a powerful language model, such as GPT-3, to predict human annotations for coherence, consistency, fluency, and relevance in summarization tasks. The ICE model is trained on a small set of examples and achieves state-of-the-art performance on multidimensional evaluation, demonstrating robustness to the choice of in-context examples. The paper also explores the use of ICE for evaluating zero-shot summaries written by GPT-3, comparing it with other systems like Brio and T0. Human annotators rate summaries from these models across dimensions such as coherence, consistency, fluency, and relevance, while automatic metrics like Rouge, BART-Score, and ICE evaluate the summaries. Results show that ICE aligns well with human judgments, whereas existing metrics consistently rate GPT-3 summaries low due to their zero-shot nature and lack of training to imitate human-written references. Limitations of this approach include reliance on an external powerful language model, which may pose risks if the model fails. Additionally, the study is restricted to text summarization and uses samples from benchmarked meta-evaluation suites. Future work could involve investigating the use of ICE for other dimensions and downstream tasks. The paper references various studies that support the efficacy of in-context learning, including works by Reynolds and McDonnell, 2021, and Min et al., 2022. It also cites other evaluation metrics, such as Rouge, Lin, 2004, BART-Score, Yuan et al., 2021, and BLEURT, Selim et al., 2020, which are used in comparison to ICE. The study concludes that in-context learning evaluators can effectively evaluate NLG tasks without requiring large amounts of fine-tuning data, making them a promising alternative to traditional evaluation methods. The paper discusses the development of a unified multidimensional evaluator for text generation, focusing on aspects such as coherence, consistency, fluency, and relevance. It introduces a novel evaluation method called in-context evaluation, ICE, which utilizes contextualized embeddings and earth mover distance to assess generated text quality. The authors also explore sampling procedures, including uniform random sampling and stratified sampling, to select in-context examples from the SumEval dataset. These examples are then annotated on a scale of 1 to 5 for the mentioned dimensions using established annotation instructions. To compare the performance of ICE with existing evaluation packages, the authors use Rouge, BART-Score, CTC, and Uni-Eval. They employ the native Python implementation for Rouge, reporting ROUGEL scores, and utilize the BART score implementation with the source to hypothesis setting for all dimensions. For uni-eval, they use a pre-trained model released by the authors, obtaining results on a test set of size 1536. Significance tests are conducted to determine if one method outperforms another. Pairwise tests are performed on 1,000 bootstrap samples, randomly selecting 80% of the test set for each sample. The results show that when using Kendall's tau, ICE with uniform sampling outperforms uni-eval with a significance level of 0.05 on both consistency and relevance. However, when using Spearman's rank correlation, ICE outperforms uni-eval on consistency, but the test is inconclusive at that significance level for relevance.